transpose of a matrix. A is a matrix of order m cross n, and the entries of the matrix are denoted by small a, I, j. I denotes the row number and j denotes the column number. Now, how transpose of a matrix is denoted? It is denoted either by A transpose or A conjugate. Conjugate. Which means small a j I. And here the orders will get reversed. Now column number will become the row number and row number becomes the column number. Okay. For the better understanding, let's take an example. Here A is a matrix given of order 2 cross 3 because 2 rows, 3 columns are there. Now, how we'll write the A transpose? Now just reverse the first row as the first column. 1, 2, 3. Row is written as here column. Here first row it is written as this first column. Now second row should be written as second column. 4, 5, 6. Now what is the order of this? Now it became 3 rows and 2 columns. See, here this is n, m, and this is n. Now here it came n and this is m. So m cross n becomes n cross m. And aij, here it is a11, a12 and a13. Here it is a11, here a21, here a31 because first row first element, second row first element, third row first element, right? So now just compare this and this. Compare a12 with this. It became a21. So ij becomes j1. Understood? Now, let's see the properties. A transpose of whole transpose becomes the normal A matrix. A plus B whole transpose. Now transpose can be given to each individual matrix and then add it. Ka whole transpose becomes Ka transpose because constant ka transpose will also be a constant. AB whole transpose, it is B transpose A transpose. This is the most important and don't get confused because this holds the reversal law. This is the reversal law. For the addition, we have just taken the transpose of the matrices and then added. Here we need to take the reversal law. First comes the B transpose, next multiplied with A transpose. It can be further continued with the number of matrices. Let's see. A, B, C whole transpose is written as reversal law, right? So C transpose into B transpose into A transpose. Okay. Now let's solve this question. A matrix is given, B matrix is given, and we need to prove this. We need to prove this reversal law. Let's do it. First, let's take LHS. Let's take LHS. Now LHS is A into B. First multiply the both matrices. 2, 1, 3, 4, 1, 0 into 1, 0, 5, minus 1, 2, 0. Is matrix multiplication possible? Yes, because here 2 cross 3 and here 3 cross 2. So 3 and 3 are equal. So here matrix multiplication is possible, which multiply directly. 2 plus 15 is 17, and this with this minus 2 plus 2 0, here 4, and here with this here this with this minus 4 plus 2 minus 2. Now it became 2 cross 2 rows and 2 columns, right? Now, this is the AB multiplication. Now take the transpose of this. What will be the AB whole transpose? Now rows become column, column become rows. This first row becomes this first column, 17, 0 and 4 minus 2 of 2 cross 2 only. Now let's solve the RHS part. In RHS, it is B transpose A transpose. Take the B transpose part. Here B is B transpose. Here 3 rows are there. Now it becomes 3 columns and 2 rows. Take this first row and write first column. 1 minus 1. Second row, second column. Third row, third column. Okay. It becomes 2 cross 3. Now just write here 1, 0, 5 minus 1, 2, 0. Again similarly write the A transpose. First row becomes first column, second row becomes the second column and becomes 3 cross 2. Is matrix multiplication possible for B transpose and A transpose? Yes. For B transpose this is 2 cross 3. So 3 here and 3 here. So it holds, right? So it follows matrix multiplication. 2, 4, 1, 1, 3 and 0. Multiply B transpose and A transpose. You'll get this with this 2 plus 15, 17. Here and here 4. 4 and minus 2, 0, this 0 and this minus 2. 2 cross 2. Now just see, LHS is equal to RHS. Hence, this reversal law satisfies. In this question, matrix A is given of order 3 cross 3 and we need to prove A transpose A is identity matrix of order 3 means 3 cross 3 of order 3 cross 3. First, let's take LHS part. A transpose, let's write A transpose. A transpose becomes, row becomes column. First row becomes first column. Second row becomes second column. And third row becomes third column. Same order, 3 cross 3. Now multiply A transpose with A. Is matrix multiplication possible? Yes, because number of rows and number of columns are same. A transpose, this is A transpose with A. It is 0 to Y, Z, X, Y minus Z, X minus Y, Z. Now multiply this with first row. First column you'll get x square plus x square. With second column you'll get xy minus xy. You'll get minus xz plus xz. Next second row with first column you'll get xy minus xy. Next with second column you'll get 4y square plus y square plus y square. With third column you'll get 2yz minus yz minus yz. Third row with first column minus xz plus xz and this with this 2yz minus zy minus zy. Again with this z square plus z square plus z square. Now what it becomes? It becomes 2x square 0 0 0 6y square 0 0 0 3z square. Not proving it, we need to find the values. Find values of x, y and z. Okay. Now it becomes, equate this LHS with RHS. LHS equal to RHS. which is 2x square 0 0 0 6y square 0 0 0 3z square. Equate this with RHS. What is RHS? Unit matrix of order 3 cross 3, which is 1 0 0 0 1 0 0 0 1. Now when you equate, you'll get x as plus or minus 1 by root 2, y as plus or minus 1 by root 6, z as plus or minus 1 by root 3. So these are the values of x, y and z.